Good evening, everyone. Great to see everyone today. Thank you for joining us today. So we'll start the conference now. My name is Karen, and together with my colleagues, we run the DevRel work here in GovTech. Before we start, we'd like to run through a couple of house rules that are up on the screen now. So first, please note that the webinar is being recorded. We will post a video on our developer portal, and the link will be shared through the chat shortly. Please feel free to ask any questions throughout the webinar via the Q&A function at the bottom of the screen. Kindly refrain from posting questions in the main chat, as our speakers won't be taking questions from there. And finally, we ask that your questions be kept to the topics presented today to keep the session meaningful. So we just have two more things to share with you before giving an overview of the program today. Next slide, please. If you have not already done so, we'd like to invite you to join our StackX community. As a commitment to engage developers like yourself, we started the StackX community over a year ago. So please join our Meetup page that's shown on the screen here. Here we will publish information on some of our deep dive sessions that we have with government as well as private sector professionals that share on a wide range of topics through our StackX webinar. Next slide. We'd also like to invite you to join our developer portal. The portal serves as a single place to discover the products we have developed. These include our API gateway, DevOps, government commercial cloud, just to name a few. It is in its beta phase, so we ask for your patience that information is being onboarded slowly. If you have any feedback on what you'd like to see more and how we can improve, we'll really appreciate your feedback. So we also have a community page where we post recordings of webinars such as this one and blogs by our GovTech teams. So our cybersecurity team has blogs that can also be found through this developer portal. So please do check it out after the webinar. So finally, allow me to run through the program this evening. First, our Assistant Chief Executive Bee Kuan will deliver the introductory remarks. Next, William and Timothy will share some common security findings from mobile apps and take a few questions. After that, Thomas and Kok Sang will then speak on building secure mobile apps, followed by a short Q&A. And finally, we'll have a combined Q&A session where you can pose questions to both speakers. We also have an optional virtual networking session at the end of the webinar. We welcome you to stay for that if you'd like to stay and interact with the speakers more. So without further ado, may we invite Bee Kuan to deliver the introductory remarks. Bee Kuan, please.
Thank you, Karen. Good evening, everyone. Thank you for taking the time this evening to attend this event, and hopefully you are keeping well even under the COVID situation. So this evening, I think the cybersecurity group of GovTech would be sharing two topics on common security findings in mobile applications and tips on building secure mobile applications. But I think many of you would have attended previous StackX webinars and probably know quite a fair bit about GovTech. But perhaps you may know or may be less familiar with the cybersecurity group of GovTech, or in short, CSG. So let me just do a quick introduction. The cybersecurity group is the government sector lead for cybersecurity, and its functions including planning, developing, and managing the key cybersecurity capabilities needed to defend government systems. So as the government pushes ahead for greater digitalization and to support the business transformation, I think it is also important for us to make sure that the systems that are rolled out are secure and that the data of our citizens are safe. CSG is responsible for a range of areas in government, but I just wanted to highlight a few areas that CSG is responsible for in its cybersecurity function, as well as how and its area of building central capabilities for the government. So for policy and planning, CSG leads the development of cybersecurity policies and standards so that we can strengthen the security posture of government systems in a manner that is sustainable, pragmatic, and effective. So this has to take into consideration the changes in the technology that we are seeing, and also to enable government agencies to leverage on cloud technologies and to support agencies' digitalization efforts. The other big area that we deal with is our role as the Cybersecurity Capability Center for the government. So CSG provides a range of things. So one of them, security design and architectural capabilities, which we implement for many of our key government systems to ensure that they incorporate security best practices and ensure that the threat risk assessments are conducted and the risks that are surfaced are addressed. We also help to build the DevSecOps engineering capabilities, which are, of course, to embed inside the software development cycle to safeguard our application systems. We also defend the government's systems and citizens' data through active monitoring of security events and threat hunting capabilities that we have built as part of our government SOC. We also have a team of highly skilled technical engineers for malware analysis, forensic capabilities to investigate and to respond to incidents. In addition, we also provide red teaming support to agencies, and we help build cybersecurity products to meet the needs of the government. But in all this, I think CSG does not work alone to ensure the security of our systems. I think we work very closely with the tech community through the government vulnerability disclosure programs and the bug bounty programs. So the effectiveness of this program is no small part due to the many white hat hackers in the community. And they have been very, very supportive and have been actively reporting security vulnerabilities to us. And of course, these have helped us to uncover blind spots and to strengthen our systems. So to contribute back to our tech community, I think CSG also share some of our key learnings that we have found so far, and we share the insights and best practices in our Medium page, okay, which is CSG at GovTech, and as well as sharing sessions like this. So we welcome you to visit our blog and share your thoughts to help us improve and be better at what we are doing. So on that note, I would like to pass the time to my team, who will be sharing about some of the common mobile application security findings and how they can be avoided by following industry best practices. So I wish you all an enjoyable and engaging evening. Thank you.
Thank you, Ace. Next, may we welcome William and Timothy, please.
Thank you, Karen, and thank you, Bikwan. Good evening, everyone. We are from the Mobile Application Pentest team from GovTech Cybersecurity Group. Today, we'll be talking on common findings found during our pentest on mobile application. Next. So, just a little about ourselves. Today's presentation will be presented by my colleague, William, and I. We have our both respective specializations, which allow us to conduct comprehensive pen tests as we are able to better focus our research on our corresponding Android or iOS libraries and its capabilities. Next. Before we start, this is the objective we hope to achieve in today's sharing. We hope to give developers insights on certain mistakes or logic flaws made during development that leads to commonly found vulnerabilities. We'll also be recommending best practices so that you may adopt these during development after this session. Next. This is a rough overview of what we'll be covering. Next. So developers may have some preconception that the mobile environment is already very secure. This is because mobile OS are packed with features such as application signing or sandboxing, secure enclave for Apple, and Android TEE, and many more. With this in mind, we feel that security consideration might often be overlooked during development. Most of our commonly found vulnerabilities originate from either data storage or network communication. Next. To give some perspective, mobile pen tests can be split into two different phases, the static analysis and dynamic analysis. During static analysis, we aim to look for low-hanging fruits such as hard-coded credentials or maybe leftover development files from the application binary itself. As for dynamic analysis, we test the functionalities during runtime to see if we are able to circumvent any business flow or detect logic errors within the application. With this in mind, we will now share the commonly found vulnerabilities during our test itself. Next. So the first we'll be talking on is insecure data storage. Next. This is a vulnerability where developers store sensitive data in plain text on the client side. So this either exposes the users or the developers to risk, as the data stored could be users' information such as credentials, or PII to developers' information such as AWS access token or Google API keys. Note that these access tokens or API keys that we are talking about are not are developers' secret keys, not those public keys that you ship together to production on the app. Next. Here are some examples of commonly seen areas that we are able to retrieve sensitive information from. I'm sure developers will be familiar with using some of the examples on the list. We'll now see some real-world example to better your understanding. Next. So we have included an example of a commercial application. You may think that such an app with thousands of downloads and a 4+ star review should do what it says it does, such as protecting your notes, bank accounts, email accounts, and password. We'll see if this is true. Next. We found that we were able to retrieve the user's login information to access the application. So the information is actually stored locally in the shared preference, which is easily recovered. With this information, anyone with the knowledge and access to the victim's phone will then be able to retrieve the victim's stored secret. Next. While exploring further, we realized that we actually do not need the user's credentials. The secrets were also stored unencrypted in an SQL-like file. This means that anyone with access to the victim's phone will then be able to pull the SQL-like file and steal all of the victim's secrets. Next. So as best practice, we suggest developers to try to store sensitive data on the backend if possible. If the data is required to be stored on the client side because of business requirements, data should always be stored encrypted. Next. Now, we are looking at a vulnerability known as Insecure Direct Object Reference, also known as IDOR. Next. This is a type of vulnerability which happens when the application blindly trusts the user input without performing additional validation. The risk of having IDOR in your application is significant, as it may lead to a massive data breach depending on where the vulnerability resides. If it's in a critical area, the attacker usually will have an unrestricted access to information provided by the affected endpoint. Next. So some of the more critical audience may notice that we are actually presenting a server-sided vulnerability. So there are two main reasons for that. Firstly, we feel that most mobile applications require a certain level of communication with the server, and the same set of developers that is working on a mobile application will also be working on the endpoint on the server. Secondly, the way that IDOR is introduced is usually because of an oversight. For example, certain API calls made during the transition of state, users will not be able to interact with these API calls. Because of that, developers might not harden this API as it's hidden away from the users. We have an example of such an oversight that we found during a mobile engagement. Next. So this mobile application tries to retrieve the user's appointment based on the NRIC as seen from this example. In this context, it's a post-authentication fetch to retrieve users' information. Therefore, the user will have no way to alter this API call as it happens automatically after login. So you can think it as being transparent to the user. Next. However, we soon realized that we were actually able to retrieve other users' appointment just by spoofing the NRIC field. The context is still the same login. However, we are able to retrieve information belonging to another user, which shouldn't be the case, as a user should only be able to access their own appointment. With this vulnerability, an attacker will then be able to enumerate appointment details of any users they want. Next. As best practice, we suggest to developers that all endpoints should perform access control check when fetching data for the user. Next. Now we are looking at extraneous functionalities. Next. So this is a type of vulnerability when development or testing codes were not removed in production. This also applies if your code is included in production, but it's not caught anywhere else in the main body during runtime. Because if we can find these codes, it can be used to reveal additional information that may potentially help to discover other vulnerabilities. Next. So we have an example of a popular password manager on the iOS App Store. When we were researching it, the application is ranked about 3rd or 4th most downloaded password manager. We found this vulnerability result in a backdoor. So this discovery was made while we were looking at the code that performs user authentication. So the same set of code that you're looking at right now on the screen itself. So bear with me. Before we get into details, let me give some context. While performing user authentication, a simplified logic will be if input matches stored password, then login, else deny, right? So the codes that we're looking at seems pretty standard at first. Next. However, we realized we found something interesting in a line of code within the deny logic of the password manager highlighted now. So we realized that using the hard-coded string of star hex 06 hex star, we will then be able to gain unauthorized entry and retrieve the user's stored credentials. So we only assume that this is a feature used to ease development, but the developers may have forgotten to remove it during production. Because of this, anyone that has access to the victim's phone and knowledge about this backdoor will then be able to retrieve all of the user's stored credentials. Next. So as a best practice, we suggest to developers to clean up all debugs or testing codes. This includes console logs, unused codes, or functionalities to ease development. The removal of debug codes is to prevent the mistake highlighted in the example. I will now hand over to William to share the next few findings. Thank you, William.
Thank you, Timothy. Hi, I'm William, specializing in Android application security. Next. Taking over from Timothy, another common security finding seen in mobile applications is insecure authentication. Next. This happens when developers fail to implement authentication properly. When attackers understand how the authentication scheme works and how it is vulnerable, they will be able to attempt to access the application pretending to be a legitimate user. This can happen both in the mobile app, where they bypass local authentication to gain illegitimate access to the app, or in the server, where they craft requests to gain illegitimate access to accounts in the backend server. We will now show a case study on an Android app, but of course, these vulnerabilities appear on both iOS and Android apps. Next. So in the Google Play Store, there's so many apps published whose developers adopt questionable secure coding practices. Pick one out of these apps, namely this hide photos in Photo Locker app. So the main purpose of this app is to hide photos stored in the device into this app. And then to access these hidden photos, a PIN code is required. Next. When we launch this app, we are greeted with this lock screen, prompting the user to enter their PIN code. Next. Previously, Timothy has shown you that apps tend to store user data insecurely in the user's device. So if we don't have the PIN, why don't we just look for the pictures in the device itself? At first, we found where the photos were stored, and yes, we managed to harvest all the secret photos in the device. Next. But wait, after copying all the files out, we realized that we can't open and see the contents of these files at all. Yes, we have no other choice but to bypass the app's authentication to see what juicy photos the owner is hiding. Next. So we want to bypass the authentication. As an attacker, we should first try to understand how this authentication works. In this case, it is very simple. If you type in the wrong PIN, the app will not allow you access into this app and it will show you a message. To further understand this implementation behind this authentication screen, we will need to decompile the APK file of this app first. Next. So after studying the source code, we found out that the app relies on a function to check whether the PIN entered is the same as the PIN that was encrypted and stored in the device. So if the PIN entered by the user matches the PIN stored, the function will return true. Otherwise, it will return false. With this knowledge, we will rely on runtime tampering to change the return value of this function to be always true. To give a short description of what runtime tampering is. Runtime tampering is a technique where we modify the code in the memory during runtime to manipulate the logical flow of the app. Most of the time, we modify the arguments passed into a certain function or the return value of a function so that we can trick the app into behaving the way we want it to behave. And then in this case, we successfully changed the return value of this PIN checker such that it is always true, even when the wrong PIN is entered into the app. Next. So after gaining access into this app, we can now see what dirty secrets the owner of this phone is hiding. From this, we can see that he has stored his PayPal password, next, and his NRIC in his app, and probably some other blackmail material which we shouldn't probe too much into. Next. Summing up the main points of this section, to minimize the risk of having insecure authentication vulnerabilities in the app, developers should understand the authentication scheme thoroughly and identify areas which could be loopholes. Also, it is best to authenticate a user through a backend server instead of trying to code an authentication function within the app. Next. Code tampering is another class of vulnerabilities we see often. Next. Code tampering is a vulnerability when an attacker can modify the code, either in the instructions inside the memory or in the packaged app file itself, to modify the logical flow of the app such that the app behaves in ways which the developer does not expect it to behave. Next. For this section, we pick this BTT test app to show that we can decompile APK file, modify the source code, and recompile it back to access its paid features. Next. In this app, there is this option to purchase the full version, and then there's another option to restore a previous purchase. Of course, when you click on the restore full version without paying, you will be greeted with an error message. Next. So we should first understand how the app detects whether a user has purchased the app before or not. We decompile the app's APK file to Java and then study how the app works from the decompiled source code. After some digging, we found a flag the app uses to determine whether the app has been purchased before or not. Next. We then decompile the APK file to Smiley and then modify the flag found in the previous step to the value true. So the app will now think that we have legitimately purchased this app. After that, we will recompile and sign the package so that we can install it into our device. So just in case you're wondering why do we need to decompile the APK twice? I find it a personal preference to read Java over Smiley. But of course, if you can read Smiley and still understand the app fully, the previous step is not necessary. Next. After recompiling and reinstalling the app, we can now access the full version without paying a single cent. Next. Generally, to counter code tampering issues, developers should implement the use of checksums to determine whether an app has been tampered with or not, both in the packaged app file and in the memory. Running a robust check for rooted or jailbroken device and then denying access to the app for these type of devices also proved to be significant roadblocks for attackers trying to rely on code tampering to compromise the app. Next. To wrap up this section, we have shown several vulnerabilities common in mobile apps which can both put developers and their users at risk. The general rule when coding secure mobile apps is to always assume that the device which your app will run on is compromised and therefore never entirely entrust inputs from the apps to the backend server or from the user to the application itself. Also, no sensitive data should be stored on the device unless absolutely necessary. And in that case, developers should always adopt secure implementations such as encrypting all stored data with encryption keys from hardware-backed key stores or the secure enclave. Next. With that, we have now come to the Q&A section, and we will now open up to the floor for any questions.
Thank you, William and Timothy. There's one question. There are a few questions in the Q&A. Would you all like to take some of the questions, please?
Okay, so there is a question by Marcus Lee. Does IDOR apply for public REST APIs, for example, Google Routes API, or do I only need to worry about it when I'm dealing with user credentials? So, okay, I'd like to direct this to Timothy.
Right, so when talking about IDOR, I think it applies for all kinds of APIs, so REST API or other different kinds of like SOAP or anything, because IDOR is an access control type of vulnerability, which means that what it does is basically you try to request for a certain set of information, such as maybe users PII or to the system's information. And what happens is that the system does not validate whether the user have the equal access level. So maybe a guest could request for registered users information, which means which is then a vulnerability itself. And when you ask, does it apply to a public REST API? I would say yes, but you don't have to worry too much about it because like such, for your example, Google Routes API and this, they are being tested extensively because of the wide audience base. So I'm pretty sure that they are very hardened enough and they are actually pretty hardened to prevent like IDORs and such vulnerabilities. Then as for your follow-up about do you need to worry when you're dealing with user, only worry when you're dealing with user credentials, I would say that generally the rule of thumb will be that if you are dealing with any kind of sensitive information, not just user credentials, even PII or even your system informations, And all these are also points of consideration. So as long as user input is required for the system to return some kind of value, such as you take in the user ID to get users information, or for example, there are certain parameters that you take in, like for example, search parameters to return some kind of information. All these you should take all these into consideration and check for the appropriate level of access before the information is being released to the user. So I hope this answers your question.
Okay. Hi. Yes. There is another question on obfuscation. So the Gunasilan Velraj asked, does code obfuscation limit extraneous functionality and code tampering issues? So I'd like to direct this to William.
Okay, hi. Okay, so code obfuscation, right? The general idea is that your code, when you try to decompile, right, you cannot see the function names, and then some code obfuscation techniques, right? They try to make it in such a way that the app might include dead ends, or they might try to program it in a way that it is very difficult to follow. So the thing is, I mean, for security, right, we all know that security through obscurity is not real security. So we should never ever try to assume that once we put obfuscation, right, our app is definitely secure. But from my experience, right, code obfuscation is a very big roadblock for us to do security testing. So because, right, once you actually obfuscate your app, right, it's very difficult for us to go and follow and then understand how the app works. And if you don't understand how the app works, right, it's very difficult for attackers to try to go and attack your app and then try to bypass all these kind of security features inside your app. So I believe that, right, it helps. Obfuscation definitely helps in terms of slowing the attacker down, but it will not stop an attacker that is determined to reverse your app. So my general suggestion is, right, you can implement code obfuscation, but and then if you update it regularly, it should your app should be actually quite very, very hard to go and reverse engineer and then go and try to for attackers to try to compromise it. So I hope that answers your question.
Okay, should we take one more question? Then we can move on to the next presentation. William, Timothy, would you all like to choose one? If not, then we can take the top one.
Okay, I think there is two similar questions. Maybe we can lump them into one. So the first one by Julius is, how do you protect against rooted device? And then there is another by Kenneth Leong, also similar. Any way to prevent magic hide? So yeah, perhaps William can answer this.
Okay, let me answer Kenneth Leong first, because I recently read about magic hide, and then because magic hide, right, it's beyond before a certain version, right, we haven't found a way to actually properly prevent it. So what actually it was a significant roadblock for us, right, was the app uses DexGuard to go and actually check for rooted device. We haven't really found out how DexGuard checks, and then we haven't really reversed it before, but it's definitely a roadblock. It's definitely stopping us from really going from using our rooted device to do code tampering. But from I think for Android 11 onwards, right, it is not possible. I mean, I understand that Google is actually implementing new features such as a true safety net, right, to actually detect magic hide, and it's actually it's working. So I think generally, right, for Android 10 and before, right, it might be difficult, but for 11 onwards, it should be easier already. Actually, it is possible to prevent magic hide. So yeah, then so the next question is about rooted device. I think generally it's generally for Android, right, it's just through, there's many ways to detect, like let's say detect whether a device is rooted or not. Like let's say you can check whether the device is, there's this SU binary, or maybe, yeah, or maybe there's this certain folder that exists in the system folder. But I think, right, for developers, right, generally using a library that's such as root beer, right, that is published on the GitHub, or maybe a commercial product such as Dexguard, right, it makes it much easier for them to actually detect rooted device and then block them up. But of course, if once a reverse engineer manages to find out how these detections are done, right, they can actually use code tampering to stop, to bypass all these checks again. So if you ask me, right, I'd say there is no 100% sure way, but there's a way that can prevent like most attackers from being successful. So I think for iOS, right, I would like to direct to Timothy to answer.
Hi, yeah, so back to the question will be on protect against rooted device. So there are actually many ways to do it, but to a certain level, okay. So there are a few things that we look at. Firstly, so we know that there are many application protection like sandboxing. So what an application can do is that you try to jump out of application sandboxing. This is a very telltale sign that if you're able to jump out of your own directory that an application is supposed to be in, then this is one telltale sign that it has been rooted or jailbroken. There are a few examples, especially for iOS. You can just try to open something in Cydia. Because once you are able to use deep linking to open something in Cydia, this is a second telltale sign that yes, Cydia exists. You can open it. Yeah, the application is rooted. And then there are still many different techniques that developers can use to do, like trying to write into a restricted area like /etc or the root partition. Then also you can look at, so there are these are the lower level ones. Then for the higher level ones, you can do is that you can include like debug guard, which means that this will require you to have some idea of the kernel level, where you need to learn about like how to use ptrace. So what the people does is that you set up a canary within a certain memory region, and then you know the checksum of the canary. So when your device is within a rooted state or whatever, you can check against this canary to know that if there's any function that is being hooked on, or there's tampering that's being done to. So this is a second level. So you are taking it a step further from just by checking whether it's rooted. Now you are looking into whether your application has been directly tampered with. And there is actually many more. So what I do say is that actually on our second session, which we will go through more about the resiliency testing. There are more information about protection against rooted or jailbroken devices will be covered during the second session. Thank you.
Okay, thank you very much. Next, may we invite Thomas and Kok Sang to share, please? Thank you.
Hi, a very good evening. Thank you, Karen. Thank you for joining us today. My name is Thomas, and together with my colleague Kok Sang, we will be sharing on building secure mobile application using OWASP MSTG and MESVS. Next. Similar to my colleagues William and Timothy, Kok Sang and I are also from GovTech CSG Mobile Application Pen Test Team. Our day-to-day job is to safeguard government applications through VAPTs, adversary simulation exercises. Additionally, we also take on research role. So for Kok Sang, he's actually specialized in iOS user space research, and for me, in Android user space research. Next. So the objective of the sharing today is to introduce OWASP MSTG and MASVS, and how your organization can adopt them to assess your application security hygiene. Next. So here is the brief agenda for this sharing. Next. Okay, so OWASP is actually a worldwide non-profit organization, and it actually stands for Open Web Application Security Project. So they focus on software and hardware security mechanism, and they do conduct trainings, conferences to educate users on security-related matters. So some of their key features project OWASP cover OWASP Top 10, be in IoT, web application, or mobile, MASVS, web security and mobile security testing guides. Next. So I'll first start with MASVS, and Kok Sang will take OWASP MSTG shortly. So MASVS stands for Mobile Application Security Verification Standard. And the objective of MASVS next is to offer baseline mobile application security hygiene. This includes defense in depth measures and also resiliency protections against client-side threats such as routing, jailbreaking, and also app tampering. Next. So MASVS provides generic standards that defines the security requirements applicable for mobile application and its OS platform. So these requirements are actually based on level that can be identified by the developers or system owner when assessing your application overall security need. And then this standard can then assist developers to build a secure mobile application. Next. So all in all, MASVS has been grouped into 8 different categories based on their technical objective and scope. This ranges from architecture, design, threat modeling to network communication, and also resiliency requirements, which are all tangible to application and its platform security. And this standard actually covers the best practices that we address the vulnerability shared by William and Timothy earlier. Next. So as I shared earlier, MASVS have this flexible level requirement. So the various requirements are actually L1, L2, and R. I'll first start with L1. So L1 stands for level 1, which fulfills the basic requirement in terms of code quality, handling of sensitive data, and its interaction with the mobile application. And then L2 actually introduced more advanced security controls that goes beyond the L1 requirement. And lastly, R for resiliency, where resiliency is introduced to protect against mobile app client-side attacks such as app tampering, reverse engineering to extract sensitive code or data. So the different combination reflects the different grade of security and resiliency, and this flexibility allows system owner and developers to actually better evaluate their application overall security posture. Next. So here are some examples. Generally, all mobile applications should fulfill the L1 requirement, and any applications that deals with PII should follow the L2 requirement, which has more advanced security controls. So mobile games should have an additional resiliency requirement, and this is to prevent users from modifying the game integrity, such as tampering your game score. And lastly, all banking, health-related application, or any application that needs to store or deal with sensitive data should adhere to L2 plus resiliency requirement. Next. So using MASVS as a checklist, we first show that you can actually decide the L1 and L2 requirement based on the checklist if you can visit the MASVS guidebook. And next. And then again, similarly, for example, this category, we includes each individual requirement in a very generic form, such that system owner can understand easily and also developer can work on it. In fact, the more technical write-up is actually inside the MSTG, which Kok-san will share later. Next. So how do you use MASVS? And today I'll be sharing with you some tips when you would like to adopt MASVS. So firstly, using it as a metric, MASVS can be used by security researchers to evaluate the security standard of your mobile application. And secondly, as a guidance, MASVS can provide guidance for developers during the development and testing phase. Lastly, to use as a procurement measure, metric itself, this is mainly for system owner. MASVS can actually provide baseline for security verification when your system owner want to engage external vendor to perform verification. Next. So what are some dilemmas when using MASVS and how should you follow? So generally, we recommend that users should need to evaluate the effectiveness of each requirement, because not all requirements are actually applicable to your industry or to your application. So for example, if your application do not communicate with any backend server, you would not need to require to implement like SSL certificate pinning to your mobile application. Secondly, users that uses MASVS can use this practice or this standard, in fact, as part of your threat modeling selection at the start of your application development phase. This is to help to address the security gaps for your application. So for example, some threat modeling requirement includes like update mechanism or the policies behind your application that is it aligned with your country laws and regulations. Next. I'll pass over to Kok-san to share with you more about OWASP MSTG.
Hello all, I'm Kok Sang from Mobile Application Pentest team focusing on iOS, user space and research, and I will be taking over this presentation to talk about OWASP MSTG. Next. I'm sure my colleague has just talked about OWASP MASVS. So what is OWASP MSTG? MSTG is known as the Mobile Security Testing Guide. MSTG is a testing guide and checklist which serve as a baseline security requirement. Some common misconception is that people often mix up MASVS with MSTG, or they might think that they are entirely the same. As shown in the slide, MASVS is a set of requirements that can be used in apps planning, architecture, design stages. Both OWASP MASVS and MSTG addresses different needs. Next. MSTG describes the technical process and aids developers, penetration testers like us, on the expert on how to test various components. Next. MSTG is a technical manual to aid developers on how to test and address mobile security issues. You can think of it as MSTG is the groundwork and that provides verification steps for each OWASP MASVS requirement for a given mobile application. MSTG provides evaluations via static and dynamic analysis of mobile-related findings. For example, all the mobile findings that are shared by our colleague Timothy and William earlier are actually tagged under a MSTG category. MSTG also groups test cases into MSTG ID tags with various categories such as network, resiliency, or authentication based on the nature of the test cases. So to conclude using a diagram, MSTG focuses on the discussion of test cases and the technical aspects, and MASVS focuses more on the security requirements level needed for a given mobile application. It is important to note that MASVS, MSTG, and checklists are all closely related. They all map to the same basic set of requirements. Next. Okay, so how do we use the MSTG guide effectively? The guide shows the high-level usage of MSTG. Inside each MSTG ID text, there is a portion of the overview which describes what is this particular test is about and the expected outcome. Next. Then there's a static analysis section which contains the code snippet on how does the phone does its check and best practices. Next. Lastly, there's this dynamic testing portion which actually tells you how or what will be the outcome dislike, and also the steps on how to attempt to do the test using various open source tools or techniques. Developers can follow the flow to understand the context by first reading the overview of the testing before diving deep into the technical aspects. Let us visit the QR below and take a look at MSTG Resilience 1, which is jailbreak detection. Okay, once you guys scan the QR, it should direct you to this webpage. The overview actually explains on what is this jailbreak detection check about. By reading on, the guide also introduces some of the different techniques you can adopt to check if the mobile app is running in a jailbroken phone or not. In some of the section, they introduce code snippet of various jailbreak detection techniques on what are the keywords that the mobile app is checking to determine if the phone is in a jailbroken state. Some portion, such as checking file permissions, actually introduce the code snippet on how to check for file permission that a jailbroken phone would potentially have. Lastly, the guide actually guides the user on how to actually bypass jailbreak detection check via dynamic testing. Next. With all the OWASP knowledge, we now want to apply it in our mobile application. We can adhere MSTG in the SDLC pipeline. Next. First, we can use MASVS as a security requirement to ensure mobile app is secure by design. It can be used along with threat modeling to determine the appropriate set of security controls for a particular mobile app. We can then introduce runtime application self-protection or RASP tools to provide immediate solution to detect and prevent real-time attacks such as runtime tampering, hence addressing MSTG resiliency requirements. We can also use static analysis security tools or SAST tools, in short, to perform source code analysis during build time of a given mobile application. Lastly, we will adopt MSTG practices in the form of checklist or a testing guide, which can be served as a baseline for automated mobile security tools and manual mobile penetration testing. Mobile security tools are automated tools that are mobile-oriented and employ both static and dynamic analysis to scan the app binary for mobile-specific vulnerabilities. The results are aligned to MSTG. For manual mobile pen tests, the intent is to assess the mobile app holistically, simulating like an actual attacker. Next. If you are interested to know where to obtain this guide, please feel free to scan the QR code here. Feel free to download it, use it, or even share it with others. As all these standards are from an open source community project, developers with strong views and insights are welcome to join this community to contribute. Okay, next. In addition to MASVS and MSTG, CSG also has a Medium page that shares interesting technical articles from our colleagues in GovTech. The frequency of our posts is about one article weekly, so be sure to scan the QR code and follow CSG Medium. Next. Okay, we have come to the end of the presentation, and we would like to thank all of you guys for taking time to attend our StackX event. We can start the Q&A session now. Any questions related to mobile vulnerability or OWASP, please feel free to ask us. Thank you.
Okay, so let's start the Q&A. There are still some questions pertaining to the previous session. So let's get through them. So there's one question on by Kenneth Lee. So the question goes, in your example, how will you envision the basic theory app developer best protect his paid features? I would think moving the unlocking of the premium feature to a back-end remote functionality to be more logical rather than to be based on the app logic. Could you share some thoughts on this? So let's hear from Timothy.
Yeah, so hi Kenneth. So to your question, I think there are at least there's two of them. Okay, so address the first one will be the thoughts about how would they protect the paid features. I think generally our recommendation would be totally the same as yours. So the best way that you can protect your paid or premium features will be to move them to a backend server instead of hosting it on the mobile phone. Why so is because let's just talk about unlocking the premium features on your mobile phone. We can go about it. There are many ways that we can actually bypass this paywall or these premium features on the mobile phone. Like an example that we have saw would be that changing the Boolean flag. But of course, some smarter developers would make things even harder, like breaking the paid features into like different functions or hiding encrypted strings and all this. But in the end, nonetheless, as long as an attacker or somebody that wants to get paid features for free, then they will be willing to go the extra mile to try to reverse engineer and slowly defeat all your paid features check that has been placed. So totally agree with you about what you say about moving to the backend, because as long as it's on the backend, right, and of course you also need to then look out on those but there's also another set of considerations when you're moving to a backend, because then you have additional things to look out for, because you will need to look at the OWASP for the web vulnerability. Then also another thing will be some of the trade-offs, because sometimes for premium features are just graphic based or UI based compared to other paid features that unlock the full app. So I guess that as a developer, you might also need to consider what are the trade-offs between moving some of the features on the mobile device itself to server side versus just by keeping it there. I hope this answers the question.
Okay, let's move on to the next question. There's a question by Alif on Android. When dealing with API keys, we will try to encrypt using key store or master key. Function encrypt string A. If obfuscation fails and exposes the string A during decompile, then what's the alternative? Is it JNI? Let's hear from Thomas.
Okay, hi Alif, thank you for your question. So basically, JNI is one method that you can use as an alternative to prevent the master key be reviewed during decompilation. Alternatively, there's also actually RSAP, runtime application self-protection tools that can actually help to protect, such as TextGuard or EaseGuard. So these are actually tools that we recommend also that can help you to protect your master key or any API keys that your app might review when a security researcher decompile your mobile application.
All right. Next question. Is there a way to 100% detect root detection? Should we hear from Timothy?
Hi. Yeah. So is there a way to 100% detect root detection? Let me just first we will look into how does root detection work. So when it started, it was just checking whether you can break out of sandbox. For iOS, you will see if there's CDR. Android you try to write into some places like /etc or places that you're not supposed to write into, and then this is root detection, right? And there's more than that. You can implement even more sophisticated way of detecting it, like trying to look for system flags, check for different files, and even try to perform things that jailbroken application can perform. But then again, I would like to say that this is actually a cat and mouse game, because it's like the police and the thief. So when developers tries to patch out or try to improve their game on detecting whether if the device is rooted, then of course security researchers will also up the game. Then it will always be this cycle where each side tries to one up each other. But I strongly believe that even though you cannot have 100% root detection, but what you can do is that you can deter 90% to 95% of the lower level skilled security researcher if your application is that critical. So then again, if a determined security researcher is determined enough, they will still be able to bypass your detection and perform their security research. But I think blocking about 95% to 98% of all the other people will still help your application in achieving the protection that you required. I hope this answers your question. Thank you.
Okay, thanks, Timothy. Next, we have a question from Julius. What SAST tools do you recommend for React Native applications? Let's direct this to Kok Sang.
Hi. For SAST tool for React Native, honestly, based on my opinion, I wouldn't say that there is a specific SAST tool that can actually target a specific language for such as React Native. So in general, some people actually use check marks. Some of them they use barcode. Sometimes they can perform React.js static scan with Burp static scan and Burp Buddy, but the thing is that it requires Burp Suite Professional. So my opinion is that it is best to run check against multiple SAST tool to confirm that the SAST tool is indeed doing a very comprehensive scan results. I hope that answers your question.
Okay, thanks, Kok Sang. Next, we have a question from Lip Hong. Hi, can I understand how often is MASVS and MSTG updated since it is contributed by open source community? Can we have Thomas answer this?
Yeah, hi, Lip Hong. Thank you for your question. So because MSTG and MSVS are actually by OWASP and they are open source, contributed by the open community of developers and security researcher, I just did a quick check, and MASVS, MSTG, they actually have up to 3 to 4 commits to actually improve the standard of these guides. So in fact, they're also looking for new standards for example, React Native application or application written on Flutter. So to answer your question, MSTG and MESVS are actually frequently updated, and all this contributed by researchers and developers are actually moderated by a group of moderators. So this is to ensure the standard of MESVS and MSTG is up a certain level.
Thanks, Thomas. Next, we have a question from Kati Ponusami. Is APK decompiling still possible if ProGuard is enabled? Let's hear from William.
Hi, Kati. Yeah. Hi, Kati. Yeah, it's actually possible. You still can decompile the APK, but what you see inside, right, it's going to be, some parts cannot be properly decompiled. Yeah, from what we see before, right, some functions cannot be 100% decompiled. But it's still actually possible to pick out certain parts of the code to see certain parts. Yeah, but it's not entirely legible at all, but you still can decompile. So that's I hope that answers your question.
Okay, thanks, William. I think we still have some time. So next question by Jackson Lim. Please share your experience with any vulnerabilities with JSON Web Tokens, JWT, on both Android and iOS mobile apps. So I'd like to hear Timothy.
Hi, Jason. Jackson, sorry. Yeah. So actually, for JWT, right? I would like developers to think that you just need to know that JWT works the same whether you are developing for, like, for example, a Java Spring, that means a web application, or a mobile application, because essentially JWT itself is an object, right? Like it's an RFC to tells you how this object is supposed to be. So whatever kind of vulnerability that is on JWT will be inherent whether when you're doing it during the web or when you're doing on mobile. So let's say if you use WIP encryption, for example, I'm pretty sure you can't do it now, but let's say you specify encryption as none, then that will be the algorithm risk. So JWT as itself, I believe that the whole RFC itself is secure. But then the main problem or the experience that we have while performing engagement is that developers use it insecurely. For example, I'm not sure if all of us know it. JWT is actually encrypted in, not encrypted, encoded in base64. But for example, you can still sign your JWT token, but because it's encoded in base64, we can actually see the payload within the token. So for developers, if you actually put the password within the token, right, we can still steal the token, then decode it, and then you will retrieve the password from the token. So what we are talking about for JWT is whether the implementation of your JWT token and how you use it, whether it's secured or not. So, and the experience for mobile on Android or iOS will be the same as on web application. Yeah, I hope this answers the question.
Thanks, Timothy. Next, we have a question from Kenneth. Any security testing tools for Kotlin, example 45? Thomas, can you take this?
Yep, sure. Hi, Kenneth. Thanks for your question. So basically, you answer your question also. So 45 is one of the security testing tool that you can use to evaluate Kotlin source code, especially when you run through source code scanner. Alternatively, there's also like tools like checkmarks that also do source code review. And once your application is built, in fact, if your application is written in Kotlin, you can use open source tools such as mock-SF, whereby they will actually decompile, evaluate, and flag out sensitive information inside your applications.
Thanks, Thomas. Okay, there's a question from Andy Nugroho. Any recommendation to store access token or refresh token securely that can still allow it to be accessed by multiple apps by the same publisher or developer? As mentioned earlier, the shared preference is not secure. Let's hear from Kok-sang.
Hey, hi. To store access token, refresh token, access token, they publish multiple apps. I would say that access token is something that can be very sensitive, and I would recommend that for any sensitive tokens, in fact, should actually be stored inside the keychain itself. Yeah, I think that online there on Apple there are also guides on how to actually retrieve the access token from the keychain, so they can also be accessed by multiple apps. I mean, on a best practice, never ever store any sensitive tokens in the user space area. Yeah, and also always encrypt the token first before you store in the keychain, because there are also open source tools that can actually expose the keychain contents out. Yeah, I hope that answers your question.
Okay, thank you, Koksang. Next, we have a question from Melvin. The examples are Android apps. Are iOS apps as vulnerable? Maybe Timothy can take this.
Hi, Melvin. So I would like to say that whatever that we print up on Android, you can think of it as they will have their iOS counterpart. So for example, on the third vulnerability that we presented, the extraneous functionalities were actually an application from iOS App Store. But that aside, there are a few places, like let's say insecure data storage that we were talking about at first. You can actually look into different places like the info.p list. So usually we'll find developers' credentials or AWS secret keys that are packed within the info.p list. Or for example, insecure authentication. So what happens is that on iOS, there's this local authentication context which developers will have to use for biometrics fingerprint. So all these places, they are pretty sure they have their Android counterpart, which is what we have been showing here, and then they are also as vulnerable. And what we hope that developers can take away is that mobile devices or mobile application is not as secure as they think. So whether it's be it for Android or iOS, there are many different ways that we can actually test them or circumvent any kind of logic flows or the business logic. And actually, if you want to know more, or if you are more interested about whether if iOS is as secure as you think, you can actually look into the MSTG, because they have a testing guidelines that actually outlines what are the different places that on iOS that you can actually test to see whether if it's that secure. I hope this answers the question. Thank you.
Okay, I believe we have time for just one last question. There's a question from Aaron Lee. Is MDM sufficient to prevent said attacks? I'd like to direct this to William. MDM being mobile device management apps.
Oh, sorry, I was having problems with my Zoom. Okay, hi. So mobile device management apps. Can you give an example?
Okay, maybe I'll take this question. So mobile device management are applications like they are meant for enterprises to implement for their bring your own device or even company issued applications. So in general, they still work in the Android user space, and sometimes they do require certain device administrator rights for the application to administer the policies. But in this case, since they still reside in the user space, it's still possible to prevent, it's still possible to conduct these kind of attacks such as runtime tampering or even root bypass, even in the presence of such apps. Yeah. So because similarly to a mobile antivirus, all of these apps reside in the user space. So they have the same privileges as any other application that is not a system app. Yeah, so it will still be, it's useful to deter against attacks, but number one, it's not foolproof, and number two, you have to get agreement from the user to actually install the MDM. So it's not not a surefire way to solve this problem. Yep. Okay, I think that's all the time we have for the Q&A. So I'll hand it back to the organizers.
Okay, thank you very much. If we could bring the slides up. Okay. Thank you everyone for your questions. It was a very interesting session. Gentle reminder that the webinar recordings can be found on our developer portal. We hope you'll visit and explore the site. Next, we'd also like to share that we have some career opportunities in GovTech. The QR code here will lead you to our career page, so you can take a look at the available roles. So we're looking for a wide range of roles, for example, cybersecurity, software engineers, DevOps, etc. So please feel free to share this with your friends who have been displaced during the COVID period or friends who are looking for opportunities. We are offering both temp as well as perm positions for experienced tech professionals like yourself. So finally, before we end off, we'd like to invite everyone to tell us, the next slide please, tell us about what you think of this webinar. Your feedback is important, and please help us fill in this short survey so that we can improve for future events. The QR link is on the left side. So I'll also like to invite everyone to join us on our StackX Telegram channel. Our speakers will be joining us, so please feel free to raise any further questions you have on this channel. The QR code is on the right. So once again, thank you everyone for joining us, and big thank you to Bi Guan as well as the speakers William, Timothy, Thomas, Gok Sang, and Sihan for moderating the questions as well. We all hope you enjoyed the session. So we'll begin the virtual networking session. If you'd like to stay back and speak more with the speakers, please kindly raise your hands. And when speaking, please identify yourself before posting the question. Thank you.
Thank you, everyone.
If anyone would like to speak and interact with the speakers, please raise your hands. Hi, Marcus. If you could unmute yourself and share where you're from before asking the question.
Hi, my name is Marcus.
Hi, Marcus.
Yes, I'm actually currently an intern at a company. So I'm actually doing cross-platform mobile application development. So, as you all know, cross-platform is both Android and iOS, like within the same like IDE. So I was just like thinking, like if I want to do testing, like is it easier like on a cross-platform, or is it easier if it's done on like Android Studio and like Xcode by itself? Yeah, that's my question.
Hi, Marcus. So what do you mean by testing it on cross-platform on the Android Studio or on the Xcode compared to testing it on your IDE? Are you saying about source code analysis, or are you saying about testing the app when you're or during runtime? Marcus?
Both. What I mean is both static and dynamic testing.
Oh, okay. So if you're talking about static testing, right? Then then you don't need to worry about testing it on the Xcode or on Android Studio, because there are the SASTs that does static analysis of I assume that you are using React Native, so there are those code scanners that will scan for you for React Native, and I think if you do a bit of Google search, there's quite a few of products. So I also don't want to be promoting anyone across others. Yeah. So for the static part, this is usually what we do. And also on the developers part, right, like I was sharing about insecure data storage. So on the developers part, I think you need to make some due diligence, or you need to be disciplined enough, because I know that as developers, sometimes we get lazy. Like for example, we hard code some strings that has an access token, or we try to store data in easier places because it's easier to write. But then on security wise, of course, it's not as secure. So then this will be some discipline on the static part on your codes. Try to make sure that you do not put any access token, API keys, or store data, or some of the methods that we shared today insecurely. This will be on the static part. So on the dynamic part, right? What I would say is that there will be a learning curve. Why is there a learning curve? Is because that even though you say that it's on cross-platform, so usually when it's on cross, one good thing is that if it's on cross-platform, right, actually you just, in my opinion, you can just test on one side, because what happens is that the React will just churn the code into Xcode, and then for Java on Android. So then you can test on one side, and based on our experience is that usually if you can replicate or you can find this vulnerability on the Android or the iOS side, right, then the same vulnerability will be present on the counterpart. Yeah, because you are using cross-platform like React Native, right? Then if then to go like a step further, like how do you test them for dynamic testing, right? So the easiest or the fastest way would be that if you look at the slide, there's the MSTG. And why do I keep directing you back to MSTG? Because within the gig book itself, right, they will list down certain tools, and then techniques, how should you test, with examples like this is what you'll see. So when you try to test for this is what you see, and what are the commands you type to test your application. And again, we'll say that dynamic will have a steep learning curve, but you can still start slow. Refer to MSTG, and if you want to move on further, then I guess Stack Overflow will be a very good place to start to further your research. I hope this helps to answer your question.
Yes, okay, can. Thank you. So just one more quick question. So does GovTech use cross-platform or when developing their mobile applications?
Oh, okay. For this question, right? I can't say that GovTech use one or another. So this will be actually this kind of question. In my opinion, will be for the project leader or the project manager to decide, because there's pros and cons for using cross-platform or to develop platform independent.
Yes.
And the pros and cons will be depending on what you're doing. How critical your application is, or what is the timeline for you to get the project out. And because there's a lot of different consideration, right? I don't think that there's a set to go to, like to use cross-platform or to be platform independent. So to me, this kind of which one should you use, right, should actually be project by project basis. So there will not be to go to when you have a new project and then you say I want to use React Native as compared to independent. Platform dependent. I hope this answers your question too. Thank you.
Okay, can. Thank you, everyone.
Thank you. I think we'll just take one last question from Thomas. By Thomas.
Yeah. So I have a question from Chebun. So hi Chebun, it's been a while. So your question is, how often do you all face a dilemma in categorizing an issue in a mobile app as a mobile security issue or web security issue? So all in all, we wouldn't want to like differentiate mobile security or web security, but we often look at mobile security issue from the platform perspective, mainly from the mobile client, the device itself. For example, the storage of the sensitive data that's stored in your mobile device, or any API call that exit from your mobile application to the backend server. So usually that's the I would say the playground for mobile security issue. However, often some of the mobile applications do contain web security issue, especially when they fetch any information back from the backend server, or the application launch a in-app web view. So that is also web security, but often we also bring it into mobile security issue when we evaluate the security aspect of these vulnerabilities. Hope that answered your question.
Okay, thank you, Thomas.
1 minute, I'm typing to Wilson Tan on his question.
Tony would like to ask a question.
Hi, can you hear me?
Yes. Hi, Tony.
Just a quick one. Actually, it's not about tech or development question. Previously, I think you all gave me an email to write to regarding collaboration. So I've written about maybe a week or so ago. I haven't got a reply. But basically, I do have some projects, social community projects that need the access to some of these tools that GovTech has developed. For example, the SG QR code, the student learning platform. Yeah, we are trying to improve on that to provide to the community back. So, any chance I'm getting to hear from your side, or should I write to anybody specifically?
Yeah, okay, maybe I'll type in the email address again. Maybe you can drop us an email to, can trouble you to send the email again to another email address, then we'll follow up with your question.
All right, thank you.
With this, thank you everyone. Thank you for speakers. Thank you A-Speak1 for everything, and thank you everyone for attending a session. We'll now close the webinar and hope to see you all again in the next TEDx.